Hi guys, so welcome to the first Kubernetes online meetup webinar. Today we are going to talk about CI/CD with Kubernetes. The guest speaker today would be Binura, who's a senior architect at Platformer, who will be joining with us from Australia, Melbourne. And sorry, my cat. Okay, right. Yeah, so we are going to start this meetup series like every week or so. We will have a webinar like this regarding Kubernetes, so all of you are welcome to join. So let's kickstart today's session. Binura, you have the floor. Binura, I think you're on mute.
Yep,
Binura,
yeah,
mute.
all good. Can you hear me?
Yeah, I can
perfect.
hear you. Yeah.
Let me just, thanks for that, Nilesh. Let me just quickly bring up my screen here. Right, can you see my screen? Is it all good?
Yeah, we can.
Perfect.
Yes.
Hello, everybody. Welcome to, as Nilesh basically went through the introduction. So this is a small series of webinars that we'll be doing around Kubernetes and the ecosystem. And this is the first of them. So what we'll be going over today is basically some of the CI/CD strategies around Kubernetes. Now we'll touch on what exactly CI/CD is. There's no real way for me to gauge what the audience is today. So I'm just going to assume a more introductory approach, since most of you might be new here and some of you might be Kubernetes gurus. So in either case, I hope there's something for you to take away at the end of this discussion and webinar. And yeah, without further ado, let's get started. So a little about me. I'm Binura Gunasekara. I work at Platformer Cloud here in Sydney. And yeah, that's about it. And before we move on, if your company is looking at transitioning over to Kubernetes, or if you're a startup looking for some free infrastructure, Platformer is giving out a 6-month free Kubernetes cluster on DigitalOcean for free. So shameless marketing pitch there before we get started, because this is really helpful for anybody looking to onboard Kubernetes. So hit us up at platformer.com and just drop a message and we'll get you sorted. With that aside, let's start. Let's talk about understanding CI/CD. Now, before we jump into anything, I want to make sure everybody's on the same page about what continuous integration and what continuous delivery and deployment mean. So basically, what is CI/CD? Now, one of the most common misconceptions about this concept of CI/CD is that it is an isolated piece in your infrastructure or in your infrastructure automation, but that's not the case. So CI/CD is, in essence, it's a key part nonetheless, but a part of your entire infrastructure and your automation setup. So it's not something like it's not like a black boxed area that you can just take and just place into your organization and just get going. There's a lot of key factors and variables that come into play when you decide what kind of a CI/CD setup or strategy you want to go for with your organization. And more often than not, when we're consulting companies and helping them automate and move to the cloud, etc., one of the biggest things that we've seen, or one of the things that I've personally seen, is Conway's law. Now, I don't know if you've heard of Conway's law, but what it basically means is that your technology stack or your applications, your infrastructure, they usually tend to reflect on your organization's actual structure or the communication structure in your organization. If you are heavily siloed, right? If you have your operations team working in a different building, not talking to the development teams, or the development team is working on their own, pushing out features without really understanding what's happening on the operation side. They create silos. And whenever these silos are present, it creates a lot of red tape for us to cross before we can actually achieve effective CI/CD or DevOps in general. Essentially, DevOps it's a new term, right? It was coined a few years back, and the whole concept was to unify the silos between developers and operations. But what's happened now in most organizations is that instead of developers, operations, we now have another silo called DevOps in the middle. So different organizations seem to have a different idea of what DevOps actually stands for. To me, to my understanding, DevOps is nothing more than a culture. It's a culture where there's a bit of collaboration and transparency and observability on both sides. Developers know what's happening, and operations also know what's happening on the other end of the spectrum. And in most cases, it works really well when you have cross-functional teams. Now, Google does it, Facebook, Amazon, all the big players, that's how they operate. They have small teams taking ownership of certain aspects of their stack, certain services, servers, maybe like multiple servers, whatever, right? You get the gist of it. So each team has ownership and they operate in cross-functional teams. That means the developers are directly involved in operations. But of course, that doesn't mean that you can't have a different IT and operations department taking care of everything else. And in recent years, it's more or less become site reliability engineering, where all of these things like the DevOps toolchain is being used. It's to sort of do the things that are required for effective CI/CD. So CI/CD by itself, as a black box, it'll never work, right? It requires a whole other substrata of other technologies and other applications to support it. Because CI/CD by itself is a very aggressive might not be the right word here, but it's a high velocity approach to handling your deployments. And whenever there are moving parts in your infrastructure and in your automation pipelines, things can go wrong. And because of this, you need another substrata of tools to take care of the monitoring, the alerting, to handle the logs, create archival storages of those logs in case something goes wrong and you need to do a post-mortem. So it is in its entirety a huge subject. Now, in this, hold on, it's much better. So in this webinar, you can't really cover all of that ground. As you might understand, it's a huge scope. And what we'll be looking at today is basically CI/CD and how we can use something like Jenkins, which is, I assume, to be still popular, especially in Lanka, to deploy to Kubernetes. So there are a couple of principles that are involved when we take CI/CD into consideration. One of the basic things is that you need to deploy often. Deploy as much as you can. Right? Don't wait until the end of the month or the end of the quarter or the next big release to deploy to production. Get your deployments flowing. So companies like Google, even us at Platforma, we have multiple, of course, not on the scale that's one of the big techs, but we have multiple deployments going to production every day. And all of that is automated, and that's zero touch. And then one of the other concepts is that no matter how much test coverage you achieve, bugs and some errors, they are unavoidable. So your CI/CD pipeline and your site reliability engineering, that needs to be set up so that in case something goes wrong, you're ready to fix it. So it's more reactive in that sense. And with a lot of things moving around, especially hundreds of deployments going through every day, even every minute, you need to have good metrics installed in your system, so you have a good overall observability of what's happening. And then the other thing is basically the whole idea around CI/CD is to automate everything that doesn't require human intervention, right? Get that out of the system, automate it, let your developers focus on building software, and let your operations and your site reliability engineering teams take care of that infrastructure and make sure it's running while everything else is just automated. So before we jump in, let's just go back here and let's look at a generic CI/CD pipeline. Now, I didn't really put a diagram in here and just hold on. I didn't put a diagram in the slide deck and just go it, because I figured it might make more sense to just go it from the start. So most of you might be able to ask any questions if you have anything, and it might help you understand the whole CI/CD process a bit better, right? So let's start from the top. So we have the developer. Most of the time, this would be you, a developer, an engineer, someone who's working on your product, your service, or whatever you have to deploy, right? And then you have your code, and then you have a Git repository. Now, I assume most of you are using Git. There's a chance that you might be using something like Subversion, but regardless, it's the same concept here. You have your code and you put that code in your repository. Now, this is the standard practice. Almost everyone does it. Now, the next step is to automate the rest of the processes leading from a Git commit all the way up to a deployment in production. So the usual process here is that once you commit your code to your Git repository, it should trigger a build. Now, this build might just involve something like compiling your code. It might be transpiling, running Webpack on some JavaScript. It might also be building a Docker container for your application, which is what we are focused on today. Now, usually what happens is that getting a build triggered after the Git repository is pretty straightforward. There are thousands of tools you can use, and you can just add a webhook on GitHub or GitLab or Atlassian Bitbucket and trigger a build somewhere. Now, most of the time, while this might be automated, another good idea is to include a code review in between this process. So what happens is that the developer pushes their code, creates a new branch, and puts a PR to a stable branch, like master or production or whatever you want to call it. And someone else comes in and reviews their code end to end and makes sure everything looks all right. You can't catch a lot of bugs in code reviews, but it does really help teams get on the same level. It does catch a few bugs, and it makes sure that the code, the architecture, the design decisions made in your code base are consistent throughout your team and even maybe throughout your organization. And that really helps with battling technical debt over time. Because by the time a feature branch or a block of code reaches your production or your stable branch, two people have seen it, right? So it's not just one person that knows what's happening. At least two people in your company know what's happening and what's going into the stable branch. So that's very important. It's very slight. Most people overlook this, but in our experience, it makes a big difference. So you create a PR. Once the code review is done, the PR is merged, and that would trigger the build. Right after the build comes the testing phase. Now, there's lots of ways to do tests here, as we'll see later on in the demo. But Usually, you've probably heard of the test pyramid. That's mostly the recommended way to run tests. You have your unit tests and then some integration tests, and then sometimes you have like end-to-end tests. And in terms of, this is a completely other topic, so we won't really go in there. But basically, what we want is, when our system is built, when our code is compiled and everything's put together in a Docker image, we want the test to be run. Sometimes, of course, these two steps can be interchanged. You can even run your tests before you run your build, but of course, it's up to you. I just prefer to have the build be built first and then run the test directly onto the build, so that you're assured that there weren't any errors during the build step. Otherwise, if you do the test first and do the build second, something could creep in during that build step, as it always does with Docker images, if you're familiar with those problems. And once that's done, what usually happens is that you end up with a set of artifacts, right? Now, these artifacts would sometimes include your Docker images, your containers. Some companies prefer to have Helm charts and update those Helm charts and then dispatch those Helm charts onto production. Some might even, what else could be there? There might be other dependencies that need to be packaged and published onto different other platforms, right? There's a lot of artifacts generated after the build step. So we need a way to handle these artifacts as well. And in our case, in Kubernetes, the most important artifact for us is the image. We need that image in some image repository somewhere so that we can pull it and deploy it onto Kubernetes. Now, if anything doesn't make sense, just give me a shout out on the chat and we can have a little discussion. But moving on from the artifact is the actual deployment, right? Now, there's a difference between continuous delivery and continuous deployment. Most people overlook it, but there is a very important distinction between the two. So with continuous delivery, what we're talking about is you do all of this and you put your image, but the deployment is not automated, right? It's very common in companies when you have, right, this deployment doesn't sit by itself, right? It's going to talk to maybe 5 or 6 other services within your organization. And if the versions don't match, or if some features aren't enabled in service A or service B, you can't really enable it in this deployment, right? You need to wait until all of those are stable, and then only can you really push this into production. So that's where our continuous delivery comes in. You do all of this, and then you wait for a manual confirmation that, all right, you can go ahead and deploy this. So that's very common. Things like feature flags, patterns like that are very common whenever you're using continuous deployment. And that continuous delivery. And then you have continuous deployment, which is like the next step in your automation plan. It's not easy to achieve, but when you do achieve it, it makes life much easier. So with continuous deployment, what happens is that all of this goes through, the artifact is built, and the deployment goes through. Now, you still have the same problems as before, right? There might be other dependent services of this service that haven't been updated. So that's where things like blue-green deployments, canary deployments, all these other strategies come about. So you wait for the other services to come up, then slowly roll over to the new version. All of these things can be automated, and that's what continuous deployment is all about. It's like the next stage of continuous delivery. And sometimes it's not easy to achieve that final step without putting in a lot of effort. But either way, that's like a general overview of what CI/CD is. And different companies go about this in different ways. This can be, they might have 5 more steps between the build and the testing part. There might be, as I said before, there might be 5 or 6 other artifacts that are published after the build step. And there might be even more deployments triggered after an artifact. So we'll look at how we can generally do something like this with Jenkins by the time we get to the demo. So let me just present this. So now we've gone over all of the CI/CD part. Hopefully everybody has a good understanding of what CI/CD represents and how it basically plays a key role when you embrace the whole DevOps concept. Now, Kubernetes solves a lot of problems for us in terms of automation, in terms of becoming operationally ready, and basically embracing that automation. So out of the box, Kubernetes gives us things like zero downtime deployments. Now, I'm just going over this for the people who might not be familiar with what Kubernetes is. So just bear with me. We'll get over to the next section in a jiffy. So with Kubernetes, when you create a new deployment, you will essentially not run into zero downtime, which is the case in most scenarios if you don't have a container orchestrator or some sort of a heavy autoscaler group set up with your VMs to sort of roll over the load balancer once a new version comes in. All right, it allows us to roll back deployments. It's just as important as creating a deployment. If something goes wrong in production, we want to be able to just immediately roll back to the previous stable version so our customers won't be affected for a longer period of time. We cannot trigger the entire build pipeline again just to revert a commit. So all of these things are provided out of the box with Kubernetes. It handles other things like auto scaling, right? Kubernetes introduced the whole concept of being planet scale. Essentially, you can have geo-redundant, highly available clusters with Kubernetes, and the amount of scale that you can achieve with it is only in most part limited by the amount of resources that your organization can afford. So if traffic just spikes up, you can have Kubernetes just scale out your application horizontally or even vertically in certain cases, and then deal with the traffic without crashing and burning. And this is something we've seen a lot during these Corona times, right? Certain websites, certain stores, they can only handle so much traffic before their service go down. But if they were deployed on Kubernetes per se, maybe it would have been a different story. There are hundreds of use cases around the world where companies have used Kubernetes to sort of scale infinitely almost to take that part away from your operation, so they don't need to worry about your service going down or lacking resources in any case in a scenario where your traffic spikes. There are also other self-healing properties in Kubernetes. There are things called health checks. So if you create a new deployment and it doesn't become healthy, Kubernetes will not switch over to the new deployment. Or if a deployment crashes, the container goes into a bad state, which sometimes happens in applications. Some exception goes off, it's not caught, and the server crashes. So in those scenarios, Kubernetes would just remove that container and put a new one in its place. And all of this will be managed without you ever having to worry about anything. So those are the things that Kubernetes does for us. But there's an entire spectrum of things that Kubernetes doesn't do, right? So it's not that Kubernetes is lacking in that sense. It's just not part of the scope of what Kubernetes is supposed to be. It's a container orchestrator, and it really does its job, right? Whenever we needs something more than what it needs to do, we go open source. There are hundreds of plugins, applications, even Kubernetes native operators that you can use to extend what Kubernetes can do. Now with things like CI/CD, Kubernetes doesn't give us a framework of any sort to do it natively. So we need to resort to other tools to get a pipeline going. Kubernetes doesn't give us monitoring, alerts. It doesn't give us those deployment strategies we talked about with continuous deployment, blue, green, things like that. It's basically you get zero downtime rollovers and rollbacks, but that's it. And while it does provide logs for active pods and pods that died like immediately, it doesn't really give you archival logs. In case something went wrong yesterday and you only found out today, you need to be able to go back and read the logs from all of your applications, from all of your pods, and figure out what's wrong. So to do all of these things, we need to plug certain other applications into our Kubernetes clusters. And that's what we basically look at here. Now, talk about all the applications, all this entire substrata of DevOps and site reliability tools is a different topic of its own. Maybe we'll get another speaker to go over it in another webinar later on. But just to get an idea, there are things like Prometheus and Grafana. You can hook up to your to your cluster, and then it'll get all the monitoring, the metrics, and it'll give you alerts. You can hook up your Microsoft Teams, chat, SMS, email, or whatever you use, just to get those alerts in case something does go down. And that's of paramount importance when you're handling like massive systems in production. There are, of course, alternatives and thousands of other tools, as we'll see later on in this video, in this webinar, sorry, as we go along. Now, I'd love to open up Grafana somewhere and show you what it actually does, but we have limited time, and I don't want to go off on that tangent. But just keep this in the back of your head if you're not familiar with these. These are things that you need to do in order to truly get that CI/CD pipeline going. It's not straightforward at all, is what I'm trying to say here. So with logging, you need to configure something like Fluentd or the ELK stack, Splunk. All of these other tools are available at your disposal. So basically, you want all the logs across all of your scaled applications to be aggregated and then stored for maybe 30 days or 2 months or 5 months or whatever your organization teams is required. So that's like a very basic overview of the substrata of site reliability tools. And the key takeaway is that there is an endless combination, right? You can combine these tools, you can even run them by themselves, and really boils down to what your team needs and what your organization needs. But of course, this creates problems later on, as we'll sort of discuss after the demo. All right, I have this very basic, bare bones diagram of how tools sort of interact. Now, this is just for the CI/CD part. You can, have all of these CI and CD tools activate after your Git commit, from Jenkins to GitHub Actions, all of this. Then you can even kubectl apply and script that and run a continuous delivery, or you can hook up to something like Spinnaker. God knows what the other tools are there now, and then have that deploy whatever was built in your build step, in your CI step, right? So that's enough talking. Let's jump into a demo here. So the reason we're going with Jenkins today is probably one of the more popular CI tools available. Unfortunately, as it may be, it's very heavy. It's definitely not my favorite. In fact, I actually hate Jenkins. I find it very confusing and very bloated in most cases. Now, what I've done here is that before the demo, I just created a small cluster on Google Cloud. So I think this is like a 2-node cluster. Wait a second, yeah. It's basically a 2-node cluster. The master is also running. So basically a 3-node cluster. The reason I went with 3 nodes is that Jenkins is heavy, runs on JVM, and you really can't get it running on a smaller cluster sometimes. I just want to keep this demo as smooth as possible. And hopefully nothing will go wrong here. Now, before we get in there, I just want to give a brief introduction to what we'll be doing. Basically, we'll deploy a small backend, and then we'll deploy another front end to talk to the backend, and then we'll put a load balancer in front of the front end so that we can access the front end from the outside world, right? Basically across the public internet. Now this entire thing will go on Kubernetes, and we'll do a bare bones Jenkins setup to get it installed and then deploy this application. So what I've also done here is that I've installed Helm. No, it's not Helm 3 or anything fancy. It's just Helm, good old Helm 2. So what I'll do here is let me just bring up these scripts. You don't need that right now. It's going to give me 1 second. So I'm just going to copy paste some of these commands. We probably won't have the time to type these in. So what I'm going to do now is quickly install Jenkins. I'm not in the wrong folder. Go here. Open bash. And then install Jenkins. Basically, I'm doing a Helm install to install Jenkins on my little cluster there. Just give it a few seconds. Let me just open up another terminal here. See what's happening. I'm just going to put Jenkins pod in the default namespace. So it's running an init container. So this might take a while. While that happens, what we'll do is we'll create a service account, like a cluster role binding for Jenkins to operate on our cluster. So that's what I'm doing here. So kubectl create cluster role binding. Let's call it Jenkins deploy. And basically this will have admin rights to create resources in our cluster. Now, ideally, we don't want to be giving cluster admin to almost any service, but for our demo purposes, to keep things running smoothly, we'll just go with an admin service account, right? Looks like we are still deploying. Let me just look at my pods with the watch here while we wait for Jenkins to get ready. Still not ready yet. It's running. Probably take a while. Let's look at our services, see if those. All right, looks like a Jenkins cluster has been installed on Kubernetes. And what does it tell us? Get your admin user password by running this. All right, let's run that. That would be our admin password. So what we'll do here is, all right. What I'm going to do is, I'm not going to expose Jenkins as a load balancer or node port or any of that. So I'm just going to use kubectl proxy, so I can map the Jenkins UI to my local host. Serial port forward, and that should be port forward in. Let me just copy back the password here and go back to local host. I think 8080 was it. And there you have it. So we have Jenkins running. Paste in our password and signing. Now, the Jenkins UI is confusing to say the least. It's confusing the first time I logged in, and I'm still confused. So what I will do here is that we'll firstly go into our credentials and go into our global credentials. This is just setting up some basic things just so that we can get started. So what I'm going to do is, because the Jenkins instance is running on GKE, I can just mount the service account from the metadata in my container. So I'm just going to say, okay, get that sorted and out of the way. And now we have a service account to work with here. Now, the next thing I want to do is, well, deploy the application, right? And to do that, I believe I need to go GitHub and create a token for me to log in with integrate Jenkins. So I'll go to my settings. Let's see, Ssh Keys. Yeah, I need to create a new Ssh key, I think. All right. So let's create a Ssh key for us to use. Just bring up. Oops. Let's create another terminal here and just generate a public key pair. I want to save it right here in this folder. Right. And all of that. Ooh, what happened? Oh, not bad. Just want to say, put it in here. Key. Done. If I do ls, I have my key here. So this is the private key. I'll just take that. Of course, I'm going to delete this after this demo, so don't bother trying to hack me or anything. But let's go back to our credentials. Let's add a new credential, just so we can integrate our Git repository with Jenkins, this step right here. So what we need is an SSH username and private key. I will just give it a global scope for now. Let's call it GitHub. Username would be Binura directly. We have that. So I added a private key here. You don't need a passphrase. Just save that. So now I have a set of credentials that will allow a little Jenkins instance to access my GitHub account and then pull the application from it. Now, let's go back to Jenkins here. Let's create a new job. How do we create a new job? Right. Yeah. So what we are going to do here is a multi-branch pipeline. There's 101 things in here that we can use. We don't use Jenkins as platformer, so I'm using Jenkins purely for the purposes of this demo. Let's just call it this demo CI/CD. Should just call it, yeah, whatever. Okay. Let's just fill in some of these blanks just to get started. Oh, there's an entire discussion going on there. Yep, we need to go back here and I'm going to title the set that private key to instance. Set that. All good. Now, description, branch sources. Want to add Git repository. Now, I've already pushed this repository to my GitHub account. And this is it. So we'll just take this URL right here. And then just paste that in there. So the credentials here is now would be my personal credentials for GitHub. I'll add that there. So discover branches. All branches get the same properties. That should be good. Discover branches, that's fine. We'll let Jenkins figure out which branch we're on. Jenkins file, yes, we have a little Jenkins file. We'll take a look at it in a bit. Maybe we'll periodically do a scan here. Because again, we're not creating a webhook to trigger it, rather we're going the other way and having Jenkins just scan it. It's only because for the sake of time. And yeah, it looks good. Let's hope it works. There's always a good chance that I've forgotten something. Now it's the pipeline activated. I think it's running. Nope, it's not what I want. Full stage view, I believe. Pipeline is not run yet. All right, so here. All right, so to create a build, we need to create a commit. But before that, we do that, let's go over our application right here. So, yep, this is what we need. Yep. Just pull this into place. So what we have here is a very small Go application. I did not write this. I just stole this off the internet because for demo purposes, it's perfectly fine. So what this app basically allows us to do is one is it exposes a little API, REST API, and when you pass in a flag, it goes into a different mode where it renders the HTML. Now, for both of these reasons, it's pretty straightforward. And what I have here is basically we now have this nasty Jenkins file, right? Let me just zoom this in for you. So with Jenkins, there's 101 ways to configure the same thing. If you want to run your builds on your cluster, you can do that. There's something called Jenkins X that does a bit more. It sort of embraces like a serverless model. You can even do that with Jenkins with plugins, but of course, for simplicity's sake, and since we are running on Google Cloud, what I've done is I've just gonna take that, dispatch it into Cloud Build, have it built and then deployed via kubectl onto our cluster, right? So with Jenkins and with most CI/CD tools, one of the biggest problems you come across is this, right? You end up with a big, ugly file of bash, and I think this is groovy. That just ends up that just keeps growing over the years, and then becomes unmaintainable. And these are some of the problems associated with using some of these heavyweight tools. But for the purpose of this demo, what we've done is we basically created a few stages, deployed to Canary, and deployed to production. I think we are running out of time real fast, so we might have to skip over some of these parts. But regardless, let's look at deploy to production, right? When the branch is master, I want a kubectl container. And then what I'm doing is basically going in here into the production YAML here, and then just changing it, right? Changing the newly built image. And that image is built with GCR, Google Cloud Build. And then you take that, and then as you can see here, you just basically do a kubectl, apply, and get that updated. So all this syntax is confusing, and I find it confusing. There's no real simple way to go about this with Jenkins and most of these tools, but it is what it is, right? So this code will be available. You can find this on GitHub if you want to play around with it. But for demo purposes, let's go ahead and just change something here. Let's call it increment. There's of course a chance that things might not work. It might just break. It's just manually scanning. So remember, we set it to scan every minute. We're not going to pick it up. No builds in the queue. Waiting for events. Nope. Let me just see if I push the correct repository here. What was it? Git reboot. We are in the right repository. Let's see why this doesn't work. Oh, something's happening. All right, there you go. It has triggered. So there is a little latency. So these are the stages that we declaratively made in our Jenkins file over here. And, it's nasty, it's not pretty. And over time, this does turn into technical debt one way or another. But there are ways to avoid that. We'll talk about that in a minute. But basically, now it's building, pushing, deploy the canary. Only if I deployed it onto the canary branch on my GitHub. But since I push this directly to master, it'll just trigger production. Now, this isn't ideal. You can have it promote images, but to do that, again, you need another plugin and you need a lot of scripting to get that in place. Now, let me just quickly see what's happening here. Deployed production, all successfully done. So kubectl, done. Let's just go back here. So we have a little namespace called production created here. Not puts. So as you can see, our application is deployed. So let me just get the services. Load balancer, this would be our external IP. Now we went from 0, hopefully, fingers crossed this works. There we go. The application is up. So all of this took a lot of work, right? I even, in fact, forgot to show you the Kubernetes YAMLs that were written here. So for the front end, we have another YAML. For the back end, we have an entirely different YAML. So, and the services are here for the back end and the front end. So as you can remember in our diagram here, what we did was we created the front end and the back end, and those are the deployments that we just looked at. And what we basically at Jenkins do was, once you push to master, we skip the code review part. We had it built, run some very small test. Like the test is, in fact, as you can see here, it's just running a silly little test here. But we basically did some testing, and then we had it directly deploy to our Kubernetes cluster with just kubectl apply scripted. And then we mounted the service account into Jenkins because we are running on Google. But, it goes for all the providers and you can just plug and play whatever you want, but at the cost of your sanity, of course. Now, that's done, right? If I change something here, let's go back here and maybe call it version 2, something. But I think we've just gone over time here. Let's call it update. We push, we create another pipeline trigger that will just do the same thing and just deploy again to our Kubernetes cluster. Now, that is like the gist of it, right? As you might have noticed, it wasn't too hard. It only took us 15-20 minutes to set up Jenkins and to create a pipeline, get everything integrated. And generally, it might have not been, it might have looked easy, but the reality is that behind the scenes, I had to write all of these YAMLs and this nasty little Jenkins file here. And if I wanted to do anything differently, I have to come back here, change these stages all over again. If I wanted to create a new environment, I would have to completely rewrite the script because it doesn't support that. So as you can see, the complexity does increase over time and depending on your requirements. So that's a very basic overall way to set up CI/CD. And most of the time, you can do what we usually do best. You can just go on Stack Overflow, on GitHub, copy these little pieces of bash scripts and Jenkins files and just glue them together and just hope it works. And that's in fact what most people do when they're working with these heavyweight tools. So remember what Albert Einstein said, right? Too many tools will ruin the soup. And this holds true even today. Especially we know with organizations, especially a platform, when we help organizations, what we usually notice is that more often than not, uh, what has happened is that they've given the freedom for different teams to choose their own technologies, their own tools, their own SRE standards. And what's happened is that it's created this information silo between teams. So one team runs Jenkins, one team runs Circle CI, and another might be running GitHub Actions, and they might be deploying to different clusters. Some of them might have some sort of standardization, some might not. Two teams cannot communicate with each other and help each other out because one person's running a completely different stack and another team is running something completely different, and there's no way for these guys to communicate and coordinate. And at the end of the day, what happens is that you just end up creating silos, more silos than you need, and that eventually adds to your technical debt, and that's something we don't want, right? So no offense to Albert Einstein, and respect for the man. So here's another shameless marketing pitch, right? So with all these tools around, there's an easier way to do all of this. So what Kubernetes loves is that it allows company products like Platformer and some other things like OpenShift. What it allows us to do is build on top of the ecosystem that is already there and make everything bare minimum. So you have the flexibility to do what you want and you have access to your infrastructure, but at the same time, you don't need to go around creating these Jenkins files, changing them every time you want to create a new environment. It seems very primitive, right? When you're embracing automation, in reality, we end up just writing thousands and thousands of scripts. And then these scripts are everywhere. There are new strategies that come into play. There's this thing called GitOps now, where every time a trigger happens, you take your bash scripts, your Kubernetes YAMLs, you put them in the repository and update it. So that repository sort of reflects the entire state of your infrastructure. Infrastructure as code, GitOps, and all of these things are there. But in reality, what we want developers to be able to deploy their applications without worrying about most of these things. And that's where I want to show you like a small demo as to how easy all of this would have been on something like Platform or a similar product. So let's just go over to our console. I'm going to log in real quick here. Go into applications, go to the demo apps. Let's just create a new demo app. Let's call it, what shall we call it? Now we need two applications, right? Remember, we made two deployments, one for the backend and one for the front end. Now, if I go back here, I'll just call the backend BE deployment. Our backend, from what I call it, runs on port 8080 and generate a default URL. No, we don't. We only want the backend to be accessible from inside the cluster, right? So save that. And that should create our backend service. Now, let's just go in here. Now, this is as easy as it gets. So I'm just going to add a repository. I'm going to use GitHub. Look for the repository here and save. Now, what this will do is all of that, it will create the webhooks in the background. It will sync up your repository and just do everything, all these manual tedious tasks that you otherwise have to do behind the scenes. Now, at the moment it's syncing, and that's it. Now all the webhooks have been added to GitHub. Now if I create a pull request on GitHub and get it approved, or if I push to a certain branch, I can just have the entire thing built and deployed in a matter of clicks. So I'll just specify how I want my trigger to run, right? So on master, whenever I push to master or the PR to master, I want my Docker file to be built. Now we already have this Docker file lying around here. So right here, just 5 lines, just a small Go application. And the build context will be the root of the repository, no build arguments. And if you recall, right, the difference between continuous delivery and deployment, these things are supported right out of the box here. So if you want to enable continuous deployment, what you can do is just flip this to yes. So when the new build comes in, it will automatically deploy into production. If you manually want to review your changes and then promote the image from your development environment to production, you can just disable that. But for now, we'll just leave it on. And once that's done, that's all good. So what I'll do here is I'll quickly, for the sake of saving some time, run the trigger manually instead of going back and creating another commit. That created our manual build, and our build should be in progress. It should appear here in a bit. So that's running. So right here, you can see all the logs, and everything is just in one place, and it's easy and very convenient. So while that's running, what I'll do is I'll create the CSCD demo front-end application. So I think this runs on just port 80. Let's get that up and running. Yep, just go back to our repository, connect that. Again, in most cases, something like this would be in 2 repositories, but we are just using one application and sort of a feature flag to switch it between the backend and the front end. So we're just going to connect the same repository. While that connects, what I'm going to do is let's also have this built on master. Whenever something changes for master, and then for the front end, I just have this fe.docker file. Basically, this is what I was talking about. You have your app, and you just pass in a small flag saying front end true, and it turns into a front end, right? It's a very bare bones application. Now, what we also need is the backend service. Now, this is also right easily available. Build context, it's all good. This should be fe. Now, if I just go back to my applications, CSC demo, CSCD backend. We don't have a public URL, but what we do have here is an internal URL. So what that allows applications in the same project to do is just communicate with each other inside the cluster without having to go over the public internet. What I'll do is, ideally this would be passed in as a build flag, but for the sake of saving some time, just do this, and then the port will be 8080. And git push, get to the running. So, yep, and that triggered the GitHub webhook that was created behind the scenes, and we already have one backend running. Build is running. And if we, I have 2 apps with the same name. Which one? 8:40 p.m. It's this one. We go to the builds here. that would also be building. So while that happens, it's really easy to add a new environment. You can just go here, create a new environment like production. You can assign whatever resources you want, how many pods you want running in your environment, and then you can just save it. But of course, there's a lot of other things that I love to show you, but for the sake of saving some time, that has been deployed. If I configured everything, it should be running. All right, that means the build is still running on our backend. Is this right? So where did I miss the configuration? Oh, this might need a bit more resources. Let's just give it some resources just to get it started. Save that. So as you can see, it's really straightforward. You have control of your entire application right here. And in essence, that's as easy as it gets, right? So everything from your HTTPS, as in your certificate from HTTPS, that's all managed. Everything is just handled right out of the box. If you want to plug in your own DNS, you can do that. So essentially, that was just a little pitch for Platformer and for things that we're doing here at Platformer. That's what we're building. But in essence, even if you are going with your own substrata of these tools, just remember to keep things standardized, because it's always easy to get excited and jump on board the next big thing. That's fine, but make sure everything sort of coordinated between your teams and inside your organization. Because if you just let it grow out of control, one way or another, you will have some problems at the end of the day. Now, that's as much as I have to say. We've gone about 15 minutes over the time limit. Hope you learned something. 1 hour is probably not enough to do an in-depth talk on like the strategies out there. There are lots of other things that we need to talk about. Things like Knative, where you can actually go serverless. There are other pipeline systems like Tekton, where you can natively build your images inside your Kubernetes cluster instead of going to another tool somewhere else. As I said before, there's a whole substrata of SRE tools that we need to talk about. And hopefully in the future webinars, we'll get someone on board to go over there. But for now, do we have any questions? All the code should be on GitHub.
Yeah. Binura, the app actually works. I think your code was laggy. I don't know if it works yet.
No, the problem was I had given like zero, almost no resources on the front end.
Right.
Yeah.
Okay.
Once that was changed, it's working. So, yeah.
Okay, so let's. Do you guys have any questions? And if you can speak up, unmute the button and speak, or you can just type it in the chat so that we can discuss further. Do you have any questions on CI/CD? Questions for Binura, me, or any other professionals out here?
Yeah, seem to be a few gurus in the.
Yeah, the chat went wild.
Yeah. Could hear the little beeping.
Okay. One of the questions that I might ask is like we spoke about how we do releases, deployments, application level CI/CD. But I mean, this is a question that's directed to everyone here. Uh, how would how would we handle the persistent layer, like database migrations, etc.? How do we handle something like that? Now deployment, we have Bluebeam, we have Canary. There are a lot of ways we can do a deployment. But how do we do something like that when it comes to databases? The schema change. And how do you guys do it? I believe a lot of professionals are here. I see Zakaria here. I see Chamila here. I think Ranga is here. There's a few here. I am on top of my head here. So how do you do something like that? What are your best tips, guys?
Anyone?
Hello.
Oh.
I mean, anyone else? I'm didn't specifically ask from Zach or anyone else, but I mean, anyone who wants to answer the question, like have a discussion how we handle the consistency layer when it comes to releases. How do we do something like that?
Yeah.
Production scenario. What are your thoughts?
I saw something in the chat.
Hello.
Yeah, who's this?
Yep.
Hi. Yeah. Hi.
Yeah, this is Shamil. So first of all, I think if you're on the cloud environment, like my first preference would be go to a managed service, right? So try that, and then in terms of like how we do the schema migrations, there'll be different tools that does the package managing. Mostly, I think even if you don't have a schema level diff generator, what we will end up having is like the DDL layer, the data definition layer, or like the column updates kind of things created first, and then sort of do the data migration script run after that. So it's mostly, I think, depends on like if you are using a sort of like a relational database kind of thing, you will need that sort of scripts. But if you are using in terms of like a NoSQL kind of database, it's like the schema migration, there's nothing like that, right? It's how your application handles the missing attributes. So it ends up being part of the code, and typically what we will do is we'll have different API versions that supports different responses up till different level. But if it's a relational database, unless you want to like opt for a paid product that does schema diffs, you could still use like SQL scripts that gets like parts of the release application that triggers another job that applies that SQL patch in your given environment.
Yeah,
it's mostly sorry.
Go ahead, Binura.
It's like in our experience, most of the complexity arises in the small window of time between the application going live and your deployment going live. I've seen certain companies first deploy the application and then have a feature flag to sort of make sure nothing crashes when they upgrade the schema. And more often than not, what happens, what the usual procedure is to run the schema update first, and then, as you said, the application. But even then, in a highly scaled system, right, when your database locks to create that schema update, like the DDL at the DDL level. It's a pretty interesting question.
Yeah, I mean, this was asked from me also by a student some time back. Yeah, another thing, that's what we do too, Chamila. As in, we write Go code and we have migration code per database change, and then we go forward with migration for a certain version, or we go back. So I think now the problem is now canary releases or production releases. Okay, they should work fine. Now I think the next problem would be that the second step where the what if the release is bad, you want to go back or do the rollback. Then, like, hypothetically, if you change a table column, then the previous version will never work. So stuff like that, I believe the only answer I had at the time, I believe still is a sensible answer, is that when you plan database migrations, you have to make it backward compatible. Like, you don't name a column, you add a new column and then copy the data in. Stuff like that. I mean, yeah, that's what I have to say.
I once worked on this very legacy PHP application. It was pretty bad, but it was serving quite a number of users. So what they did was, before the code changes went in, they would create a separate PR and a completely separate pipeline to create the database schema changes, to apply the migrations. And then they would deploy the new version of the application. And then once that goes live, what they would do is they would deploy another migration to remove whatever columns that are necessary, break that backwards compatibility. But that's basically.
Nilesh, it depends on the application as well, because I have experience with e-commerce platforms. So you have more transactional data, right? It's basically working money. So when we do deployments, we used to have, obviously it was on we on AWS, so we're using RDS. So in our you can make read replicas, and whenever you want, you can make it as a write, and you can use a read as a write. So we are in application level, in the configuration, we can have multiple reads, but only one write, right? So we were using our own DNS, internal DNS in Route 53 to traffic send the traffic. And obviously, it's a huge, a huge release change. Like, for example, if you're going, the platform was Magento, obviously. So, PHP.
Yeah.
I hate PHP. So from Magento 2.2 to 2.3, I had a very, very bad experience with regarding the database, because it's partially update the schemas and stuff. So our DB engineer had a nightmare to do that. So it went around like more than 24 hours. Our SLA was gone. It's messed up. So it depends on the platform as well, whatever the application you're running. If it's e-commerce, it's even I am asking that question everywhere with solution architects and everyone. It's still even I didn't get a proper answer like you said.
Yeah. Sometimes the zero downtime you have to forego. There would be a downtime, isn't it?
Yes, exactly. That's my point. There is a downtime anyways. So we had to put the maintenance, and we had to test as soon as possible if the schemas update or the data generated, because if there's a huge change, like for example, if you're going for a major release, in the version change, there could be new tables, new schemas and stuff. So if you're reverting back, it'd be a mess. So if you have a managed database, very, very easy, because you can isolate one database and you can point it out from the DNS back to normal. You can release the code separately. So if it's better, we can keep 2 pipelines to do that.
Yeah.
Thank you.
Thanks, Ashley. All right. So, do we have any questions? Anyone from the audience? Any other questions?
Feel free to talk about anything related to Kubernetes infrastructure. Let's have a good conversation.
So I have one question regarding platform, the application. Okay. So we are currently using EKS, okay, on AWS. So recently EKS supporting Fargate as well. So from your platform, is it possible to manage all those resources as well? Because currently I'm using AWS Code Pipeline, Code Build. Currently I don't have any requirement to change, but still I saw is Binura's demo. I think Nilesh once also gave me a nice demo regarding this. So I was wondering whether, I mean, can go for like tool like this, but what are the advantages rather than AWS Code Pipeline, Code Build and stuff?
Yeah.
Is it still possible to connect EKS clusters?
It is. Shall I take this one?
Yeah. Yes.
Okay. So basically, so the Fargate connection is basically you point get Fargate nodes into the EKS cluster as Kubernetes nodes. Yeah.
That's correct. Yeah, correct.
All right. Yeah. So in that case, it should work. It should definitely work, because what Platformer basically does is it provides a pass on top of Kubernetes. Basically, it just allows you to forego your. I think Pubudu or someone asked that question on chat as well. You don't need to write complex YAMLs. Like if you saw the demo Binura did, he didn't write a single YAML for Kubernetes or single configuration. Everything just happened, just got applied, and it doesn't matter really, because as long as it's Kubernetes, it's speaking the Kubernetes native language. So basically everything could be backed up. And if one day you decide that EK is shit and you want to migrate to Google Cloud, you can do that very easily, because all the YAMLs are dynamically generated. And as per the Zacharias question on AWS Code Pipeline, so that's something that we provide on Google Cloud Build at the moment, the thing that Binura showed. But it's two parts. It's CI and CD. So you can do the CI part in code pipe, AWS code pipeline, or
code build,
or Google Cloud Build, or DevOps pipeline in Azure or GitHub Actions, or even your own Jenkins. You can do the CI part anywhere you want, and all you need to do is, after you build it, Platformer would give you a webhook, and then all you have to do is just call that webhook on whatever the CI server you're running, and tell Platformer that, okay, we have built this is the new image, you go ahead and do the deployment, and then Platformer will do the rest. You won't need to have any YAMLs or anything. Like one of the case studies that I could say is that recently we had a production database, and then for God knows why the operations engineers who were using that database, they kind of screwed it up. HCD got broken and the cluster was messed up. And then there was this demo happening in I believe it was in 30 minutes, and it was gone. The cluster was gone and everything was red. So but thankfully they deleted the cluster and recreated the cluster again, and then connected it back again to Platformer. Now, because Platformer dynamically generates these configurations behind the scenes, we always have a backup. So behind the scenes, everything got backed up, and then everything got restored under 5 to 10 minutes, and all their services were up and running, and then they successfully went on with the demo. So I think those were the things. I mean, we'll probably release a video on what Platformer does and everything with features. I mean, we no need to discuss about those in this meetup, but any other Kubernetes questions? Do you have any follow-up to that, Arshad?
Thanks, Nilesh. If anything, I can call you, right? No worries. Thank you.
Yeah. Okay. Any other questions you guys have? Okay. So if we don't have any other questions, I believe Kushanta has just dropped a chat message with a link to the next meetup. So the next meetup would be on June 3rd, and we would be so Chamila would from LSEG would be talking about clusters as cattle with cluster API. Basically, you would be talking about how to use the new cluster API that Kubernetes has provided, CNCF has provided for you to create clusters on cloud, on VMware, etc. So you'll be talking about that, and yeah, go ahead and subscribe to that too, and we will send you the meet link when it's near. Okay. Thank you guys for joining. I mean, if you have any other questions, just hit us up on Facebook. We'll respond the ways we can. Okay. Thank you, Binura. Thank you for your time, and thank you everyone.
Cheers.
Thank you.
Thanks, guys. Have a good day. Bye-bye.
Bye.